Okay, we're ready to get started on the problems. You need to have at least attempted these problems before watching the video. It does you no good to just simply copy my solutions without trying them on your own first, okay? Okay, on problem 1, a crew has paved 3/4 of a mile of road, so they've paved part of the road. If they have completed 50% of the work, so they completed 50% of the whole amount of road, how long is the road that they're paving? So we've been practicing writing equations and solving equations in this form. So the part they've paved is 3/4. The percentage is 50%. And how long is the road? That would be the whole amount of the road. So I know the part, the percent times the whole equals the part. So my equation is going to be 50%, so 50 hundredths, times the whole length of the road. I shouldn't use that. I don't need to use that symbol. So I'm going to call R length of the road. So 50% of R is equal to 3/4. And then I want to solve this equation. So first of all, 50%, 50 hundredths, I can already just simplify that as 1/2. So I have 1/2 R equals 3/4. Divide both sides by 1/2. 1/2 divided by 1/2 is R. 3/4 divided by 1/2 is going to be the same thing as 3/4 times 2/1. That gives me 6/4. That simplifies to 3/2, which is 1 1/2. So the whole length of the road is going to be 1.5 miles when it's done. Okay. Some of you might have just, without even writing the equation and going through all this, just thought, well, if 50% of half of the road is 3/4 of a mile, then the whole road is going to be twice that, and 2 times 3/4 is 1.5. So some of you could have just done this mentally. All right, problem 2. 40% of x, 40% of some number is 35. Write an equation that shows the relationship of 40%, x, and 35. Well, we've done this, right? 40%, 40 hundredths, times x equals 35. Then it says, use your equation to find x, show your reasoning. So again, I could just use it as is here. If I want, I could use different representations of 40 hundredths. I could use 4/10. I could use 0.4. I could have converted the 4/10 to 2/5. 2/5. I could have used any of these as the coefficient of x. They are all equivalent representations. Let's zoom in a little bit here. And I think I'm going to use 2/5 because I suspect that might be easier when I'm doing the calculation. So the equation I'm going to use is 2/5 x equals 35. To get x all by itself, I need to divide both sides by 2/5. So 2/5 divided by 2/5 is just 1x. 35 divided by 2/5 is the same as 35 times 5 halves. I can't simplify. 5 times 35, 5 times 30 is 150, and 5 times 5 is 25, so that's going to be 175 over 2. And now I just, I could leave it as an improper fraction, but I'm going to go ahead and change it to a mixed number. 2 goes into 150 times, 2 goes into 35 times, so that's 85. And 2 goes into 5 twice, so that's 87, and there's a remainder of 1 left, so it's 87 1/2. Next. Priya has completed 9 exam questions. This is 60% of the questions on the exam. Write an equation representing this situation. Explain the meaning of any variables that you use. So Write an equation representing the situation. So I know 60% of the total number of questions on the exam is equal to 9. So I'm going to call the number of questions Q. Just picking a variable that has some sort of relationship to what it represents. So 60% of the questions, so 60 100ths, or 60%, times Q, the number of questions, equals 9. And again, that 60 hundredths, I could use 6/10. I could simplify it further into 3/5. I could use the 6/10 as a decimal, 0.6. Any of those is fine. And so I'm just going to say Q equals total number of questions on exam. All right, then I need to solve that. How many questions are on the exam? So again, I could use any form of 60 hundredths. I'm in the simplified fraction mood. So I would simplify that to 6/10 and then to 3/5. So I'm going to say 3/5 times Q is equal to 9. Divide both sides by 3/5. So I have 1Q is equal to 9 divided by 3/5, which is going to be the same as 9 times 5/3. 9 and 3 can both be divided by 3. And when I multiply straight across, I get 15/1, or 15. So there are 15 questions on the exam. It's not a lot of questions for an exam. Okay, moving on. So what I discovered when I was working through these initially is I just didn't leave a lot of room on this worksheet to do the work for these problems, so I apologize in advance. Problem 4 says answer each question, show your reasoning. 20% of A is 11. What is A? So we've been working on writing equations for these types of problems. So 20%, 20 hundredths times A is equal to 11. I'm just going to write all the equations first. 75% of B is 12. So 75 hundredths B equals 12. 80% of C is 20. So 80 hundredths times C equals 20. And our last one, 200% of D is 18. So 200 hundredths times D equals 18. All right, so I've got all my equations. And now to show my reasoning and answer the question is just a matter of solving the equations. So some of these I'm going to rewrite. Almost all of these fractions I could rewrite pretty easily. I could simplify them pretty easily. So 20 hundredths, if I divide the top and bottom by 20, becomes 1/5. So I'm going to solve 1/5 times A equals 11. I would divide both sides by 1/5, which is the same thing as multiplying by 5. 5 times 1/5. So I'm going to multiply both sides by 5. I didn't leave myself a lot of room to do that. 5 times 1/5 is 1, so I have 1A, and 11 times 5 is 55. So here, A is 55. If I move on to B, 75 hundredths, I could rewrite that as 3/4 B, right? 75 hundredths is 3/4, so I have 3/4 times B is equal to 12. And then I could divide both sides by 3/4, which is the same thing as multiplying both sides by 4/3, multiplying by the reciprocal. So that's what I'm going to do on both sides. So on the left side, 4/3 times 3/4 is just 1B. And on the right side, 12 and 3 can both be divided by 3, so that becomes 4 and 1, and 4 times 4 is 16/1. So in this one, B equals 16. Part C, 80 hundredths, if I divide the top and bottom by 20, this becomes, let's use a different color. If I divide the top and bottom by 20, this becomes 4/5. So my problem becomes 4/5 times C equals 20. So to get C by itself, I divide both sides by 4/5. And dividing by 4/5 is the same as multiplying by 5/4. So I'm just going to write this like that. Oops, 5/4. So 4/5 times 5/4 times 4/5 is just 1C. And here, I've 20/1 times 5/4. 20 and 4 can both be divided by 4, so that becomes a 1, and that becomes a 5. So after simplifying, I have 5 times 5/1, so C equals 25. And my last problem, 200% of D is 18. What is D? So, this one, simplifying, 200/100 is just 2. So this just becomes 2D equals 18. So here, I divide both sides by 2. So on the left, I have 1D, and on the right, 18 divided by 2 is 9. So the solution there is D equals 9. Okay, problem 5. For the equation, what is the variable, what is the coefficient of the variable, and which of these is the solution to the equation? So, well, the variable is the letter that's standing for an unknown. So here the variable is just n. What is the coefficient of the variable? So coefficient is always just the number that's multiplying the variable. So in this case, the coefficient of the variable is the number 2. And then it says, which of these is the solution to the equation? So they're asking us which of these, if we substitute it in for n, gives us a true statement. So I'm just going to go ahead and substitute it in, these numbers in. N doesn't make sense. I'm not going to substitute a variable in for a variable, so I can eliminate that right away. But first let's see, I have 2, and we're going to use this first number. 2 times 2 minus 3, does that equal 7? Well, 2 times 2 is 4. Does 4 minus 3 equal 7? No. 4 times 3 equals 1. So 2 is not a solution. Let's try 3. So 2, and we're substituting 3 in for n. 2 times 3 minus 3, does that equal 7? 2 times 3 is 6. And 6 minus 3 is 3. Does 3 equal 7? No. So 3 is not a solution. Well, we've got it narrowed down to 2. So I'm going to try substituting in 5. 2 times 5 minus 3, does that equal 7? 2 times 5 is 10. 10 minus 3 is 7. Does 7 equal 7? Yes. So 5 is our solution. And we don't have to bother checking 7. Okay. And we're almost to the end. Problem 6. Which of these is the solution to the equation 1/8 equals 2/5 times x? Show or explain your answer. Well, the easiest way to do that is to just solve this equation. I mean, if you wanted to do a lot of work, you could substitute each of these in to the equation for x and see which one gives you a true statement. But that's way more work than we need to do. We can just solve this equation. So I have 1/8 is equal to 2/5 x. I want to get x all by itself, so I'm going to divide by 2/5. And then to keep the equation true and balanced, I have to do the same thing on the other side of the equal sign. So on the right side of the equal sign, I just now have 1x. And on the right side, left side of the equal sign, I have 1/8 divided by 2/5. And I'm just going to come over here. 1/8 divided by 2/5 is the same as 1/8 times 5/2. I don't have any simplifying I can do. So this becomes 1 times 5 is 5, 8 times 2 is 16. So my solution is x is equal to 5/16, and there it is right there. Okay. Problem 7. find the quotients, show or explain your answer. So this looks a little intimidating at first because you've got all these decimals and they're in division problems. But remember, when we're doing division problems, we can eliminate the decimals by moving the decimal point the same number of spaces, the same direction in both the divisor and dividend, or numerator and denominator, however you want to look at it. So starting with A, there's 3 decimal places here, 3 decimal places there. So I'm just going to move my decimal 3 spaces to the right in both the divisor and the dividend. So this now becomes 9 divided by 1. Well, how easy is that? 9 divided by 1 is 9. Part B, same thing. I've got 3 decimal places here, 3 decimal places there. So I'm just going to slide my decimal 3 spaces, my decimal point 3 spaces to the right. And what you're doing here is you're really just multiplying both of these by 1,000. So it doesn't change. It becomes an equivalent expression. It is not going to change your quotient. So now I have 9 divided by 2. I could write that in fraction form, 9 over 2, and then just convert it to a mixed number. 2 goes into 9 4 times with a remainder of 1. So I have 4 1/2. Now this kind of makes sense because the only difference between these two problems is the divisor is twice as much in part B. So I would expect the quotient to be half as much as A, and it is. Okay, let's move on. Problem C. Now in problem C, I've got 4 decimal places in my dividend and 3 in the divisor. But I want to completely get rid of the decimal point, so I'm going to move it over 4 spaces. So I have 45, and I'm going to move it over 4 spaces here, which means this becomes, I've got a 0 there. So now my problem becomes 45 divided by 10. And again, I think the easiest way to do this is to write it as a fraction and simplify it. 10 goes into 45 4 times with a remainder of 5. And then 5/10 simplifies to 1/2, or if you want it as a decimal, 4.5. Okay. D is similar. I've got 4 decimal places in my dividend and 3 in my divisor, so I'm going to move it over 4 in both of them. I can't just move it over 3 in this one to get rid of the decimal, because you have to do the same thing. If you're thinking about this as a fraction, you can keep a fraction equivalent by multiplying the top and bottom by the same number, or dividing the top and bottom by the same number. So in this case, we're multiplying them both by not even 1,000, by 10,000. So this becomes 45 divided by 20. So again, I can write it as an improper fraction and simplify it. 20 goes into 45 2 times, leaving a remainder of 5. So I have 2 and 5/20, and 5 and 20 can both be divided by 5, so it becomes 2 and 1/4, or as a decimal, 2.25. And we noticed in this first set of problems, they had the same dividend, but the divisor was doubled in the second problem. When we doubled the divisor, the quotient was divided by 2. It was half as much. So doubling what you were dividing by caused the quotient to be divided by 2. And we can see the similarity here. Here, our dividend is the same, but our divisor is twice as much. And we notice that our quotient, 2.25, or 2 1/4, is half as much as 4 1/2 or 4.5. So keeping the dividend the same but doubling the divisor caused the quotient to be half as much. Okay, and we're done.